Hi, this is Jason. Thanks for joining us at Net.Academy today. As always, we appreciate your time. If you're enjoying the content, why not give us a like and a subscribe? And as always, feel free to leave a comment, whether it's on the way we're presenting, the topics we're presenting, things you'd like to see, things we didn't do justice to, any of that. Today, we're going to be getting into external BGP or eBGP, and then we're going to contrast it with internal BGP or IBGP. Now, we've covered IBGP already in depth, so this will be a look at its counterpart, external BGP, and then wrapping up with some comparison between the two. As always, feel free to let us know what we're getting right or not. And with that said, we're going to hop right in. Thank you. So we're going to go ahead and get started here. And again, we're going to be covering both eBGP and then wrapping up a little bit on eBGP and IBGP. So let's talk about eBGP, which just stands for external BGP. This is the BGP that's going to run between two different autonomous systems, right? So think of perhaps your enterprise with an ISP or between two ISPs. You might also run eBGP in some enterprise scenarios, which we'll talk about a little later in this course, right? So there's some specific differences in behaviors we want to take a look at. Number one, eBGP is meant to be directly connected. You could change this, but it's not very common, right? So what do I mean by that? I mean, in IBGP, when I have two neighbors, they are not necessarily directly connected. They need IP table reachability to one another, but they don't need a cable that connects them. They don't need a shared network or shared interface or anything like that. In external BGP, we typically do want that sort of thing. We typically do want a directly shared network. Because it is typically directly connected, there is no IGP requirement in eBGP, right? Why would you have one? I mean, you're already directly connected, right? Wouldn't make any sense. Because it's directly connected and because eBGP is dealing with these external routes, it has quite a low administrative distance, 1 of 20. This is directly related to that no IGP, right? IBGP 200, and that's because we don't want it taking over from our IGP. eBGP 20, because it should overwrite any IGP. And then loop avoidance is primarily done with something called an AS path check. And we're going to get more into that on the next slide. And this is a generality, not a true statement per se, but in general, I find that eBGP is more policy intense than IBGP. What do I mean by that? I mean, we're typically more strictly controlling what goes in and out externally on our external links, our external BGP process, than what's happening internal. Internal, it's mostly about propagating these routes around so that I can get outside my autonomous system when I need to. I find most configurations get more policy intensive when we're talking about what we accept or send to an external BGP neighbor. Okay? Let's talk a little bit about those AS paths in general. We talked about in the IBGP section, we spent quite a bit of time talking about the next hop attribute. There's another attribute that changes besides next hop when you enter a new autonomous system. So in this drawing here, I have AS100 in the left, AS1 in the middle, and AS300 on the right. AS100 is originating a network, 10.1.1.0/24. And it is directly connected to a router over an AS1, right? So if we look at the BGP process on that router in AS100, we will see that there is no AS path. Why? Because I don't need my own AS path in the path. There's nothing to check there. However, when it leaves, when that prefix leaves AS100 and arrives in AS1, the AS path attribute is updated, and it's updated for the exiting autonomous system. So you can see that in AS1, when I look at network 10.1.1.0/24, I now have an AS path of 100. This is pretty similar behavior to what we see with the next hop attribute in IBGP, right? It's being changed when it exits and enters a new autonomous system. Same thing when it leaves AS1 and goes to AS300, we will see that I've got an AS path of 1 and then 100. That means I originated, we read this kind of right to left for origin to closest. So the origin AS was 100. The closest AS for me to get there is AS1. So the AS path is either 100 or 101, depending on how you want to read it, right? But you'll notice what is not there is the local autonomous system, right? Again, we don't put our own autonomous system in the AS path. Now, it's important to understand that in eBGP, when we get to AS path, that's also used for loop avoidance, right? So for example, it's not drawn this way, but if AS300 was somehow connected back to AS100 and it tried to send 10.1.1.0/24 back to AS100, well, upon the eBGP process of accepting the route, it will look at the AS path. And when it notices its own autonomous system, i.e. AS100, in the path, it will not accept the route. That's the loop avoidance, right? So this is what we mean when we call BGP in general a path vector routing protocol. IBGP acts more like a distance vector, right? And then in eBGP, we're more concerned with the path. That's where path vector comes from, right? So just so you understand, that's the loop avoidance mechanism. Let's kind of take a look at the differences between E and IBGP. So in IBGP, really no BGP attributes are changed during the propagation. A BGP attribute is changed upon accepting a route from an eBGP neighbor, but during propagation within an autonomous system, no attributes are changed. And we'll talk more about attributes later on. In eBGP, both the AS path and the next hop address are changed on propagation, right? We've kind of probably cattle prodded that dead horse enough. IBGP utilizes split horizon to avoid its loops, and eBGP utilizes AS path to avoid its loops. The administrative distance in IBGP is 200, and in eBGP it's 20. Again, that's because IBGP is intended to work with an IGP, and you don't want it taking over the routing preference, right? While we haven't talked a lot about these, in the next session we will. We're going to do a lab with I and eBGP. The primary way to influence path selection in IBGP is an attribute known as local preference or local pref. In eBGP, the primary way to influence path selection is with something called an AS path prepend. Okay, I'm not going to go deep in those on today's session because we're going to talk about those when we do a demo next session. Okay, and this is not saying it's the only way to influence path selection in IBGP or eBGP, but it's the most common way. Okay, and then in IBGP, our peers can and often are far apart and fully meshed. And in eBGP, our peers are and usually will be directly connected, right? I will point out in IBGP, saying that they're fully meshed, we did talk about in the IBGP deep dive, we did talk about how that's not always the case, right? You may not always have to fully mesh them. If I have a data center in North America and a second data center in Europe and a third data center in somewhere in Asia, and they're all sending unique public prefixes, for example, and taking in unique public prefixes, there might not be any point to fully meshing because I'm not trying to make that redundant most likely. My redundancy might be built into the data centers themselves, but I'm probably not routing traffic to and from North America through Asia or EMEA, right? It wouldn't make a lot of sense just from a performance perspective, generally speaking. Of course, your mileage could vary. Anyway, that's the overview on this one. Thanks for joining, and we'll wrap up with some final thoughts. Thanks for stopping by today. As always, here at net.academy/LA Networks, we do appreciate your time. Hopefully you're getting something out of these different series that we're doing right now. As a reminder, we've covered OSPF, we've covered BGP, we've covered AWS, and we've covered Wi-Fi 6E versus 7. Of course, the AWS and the BGP are ongoing. They'll probably be ongoing for some time. I think we have another Wi-Fi series coming up as well. We're working on that in the background. If you like what we've done, please give us a like and subscribe if you're willing. And as always, you can leave comments below. This is Jason. I just want to thank you again for your time. It is really appreciated. Have a great day.